Our essential question in this video is, how do the values of h and k change the location of a quadratic graph? We just covered in the previous section how does the value of a change the shape and direction of a quadratic graph. So class, what you should be getting from this is a changes the shape and direction. H and K change the location, but they do nothing to change the shape or direction. A does that. So how do the values of H and K change the location? You should be highlighting or underlining this word location, because H and K change the location of a quadratic graph. Let's go ahead and fill out this table. This table looks a lot like the table we just did for the effects of A. Only now it's going to give you an information on how H and K affect the graph. Okay, if H is greater than 0, then the vertex of the graph is going to shift horizontally to the right. So it's going to shift right whatever number H value is. So if H is 2, it's going to go 2 units. If H is 3, it's going to go 3 units. Here's an example of that. F of x equals x minus 3 squared. Our H value here, remember you flipped the sign, is positive 3. There is no K value. This positive 3 shifts the graph right 3 units. So the vertex is not going to be at 0, 0 anymore. It's going to be at 3, 0, because it's going to move 3 units to the right. If H is less than 0, then we shift horizontally left. Here's an example. F of x equals x plus 2 squared. K is still 0. H is now 2 flipped, so it's negative 2. Negative 2 for the H value means the graph shifts left or negative on the x-axis 2 units. K does the same thing as H, only it shifts the graph up or down, which is a vertical shift. If K is greater than 0, we shift vertically up. Here's an example. F of x equals x squared plus 3. You can see that there's no plus or minus along with the x here. That means H is 0. And then our K value is positive 3. So our vertex is going to go up 3 units. If K is less than 0, we're going to shift vertically down. So in this case, x squared minus 2. You can see the K value is negative 2. Our graph is going to shift down 2 units. Let's go ahead and do some problems with this, see how it goes. All right, let me scroll down a little bit here. Okay, so let's say that we know that H is 3 and K is equal to 0. I'm going to go ahead and write that as a function, and we know that the function is going to then be, notice we're not talking about A at all here, so A is just 1. H is 3, so in the equation it turns into negative 3 squared, and the K value is 0. Because of this information, we know the vertex is of course going to be at H comma K, which is going to be at 3 comma 0. All right, so here's our vertex, 1, 2, 3, comma 0. There's our new vertex. Since our A value hasn't changed, then our A value is still 1. That means we're still going to have the same shape as the parent graph. And because A is positive, we're still going to have an upward facing parabola. So for the A value is equal to 1, it's going to be the parent shape. Doesn't change. Okay, so parent shape, and then it's going to be facing up because it's positive. So I'm going to go ahead and do my best to duplicate this. The easy way to write the parent graph, by the way, is start with a vertex. If you're going to go up, you go over 1, up 1, and then over 1, up 3. Over 1 to the left, up 1, and over 1 to the left, up 3. That will give you your parent graph. Let's go ahead and do our best. Oops, I always forget to. It's a new procedure I've learned. I always forget to actually connect those two together. I'm getting better at it. All right, there's our parent graph. Okay, so we've shifted over. Notice the way I'm drawing, class, it's not exactly the way it should be. This is an actual parabola. It looks a little bit pointy, but you're getting the idea of what it looks like. Okay, here's our first example. Let's try another one. What if h is 0, but k is equal to -2? Well, here's what our function is going to look like. Again, we're not concerned about a right now. We're just looking at h and k. If h is 0, we just put a 0 in here in the place of a. It doesn't matter whether it's negative or positive. It does the same thing. And our k value, we keep the sign as -2. You're going to see, class, a lot of times this will actually be written like this. F of x equals x squared minus 2. Notice that's the same equation. This is standard form, but it really just is vertex form, and you're taking into account that there's a 0 here for h, and so we don't have to even write it. So both of these equations are exactly the same. We know that in this case, our vertex is going to be at h comma k, which is going to be at 0 comma -2. 0, -2, there's our new vertex. Let's do that in red. The a value hasn't changed. It's still equal to 1, and that means it's the parent shape. And a is still positive, so it faces up. And now we'll go ahead and plot again. Remember our shortcut for drawing the parent shape. Over 1, up 1, over 1, up 3, over 1, up 1, over 1, up 3. And let's go ahead and sketch out a parabola. And we'll go ahead and put some arrows on that. And again, you can see the shape is the same, except for the way I'm drawing it a little bit different, but the shape is the same. But what happened is it's now shifted 2 units down. In fact, let's do this. If you look at this first one, we just went over 3 units. In this case, we went down 2 units, or -2. All right, and then the last one. What happens if we combine the effects of a and the effects of h and k? So a is -2, h is -1, k is 3. Here's our a value, here's our h value. We see we flipped the sign. Here's our k value. Let's go ahead and identify the vertex. The vertex we know is hk, which is -1, 3. Let's plot that. -1, 1, 2, 3. There's +3. Okay, so there's our vertex. Now, what does -2 do? If a is -2, we have a number smaller than -1. That means we're getting a stretch, and it's upside down or reflected because a is less than 0. It's a negative. So stretched and reflected. So to stretch this, I'm not going to make a perfect graph here. I don't care exactly that you do it perfectly right, but let's just go ahead and draw a stretched graph, just so we can see that it's going to be stretched from the normal parent shape. I'm not sure what that just did. Let's open this up. Oh, it's about right. Okay, let's finish it. Oops. The problem is that once I draw it, I can't undraw it. Let's try it one more time. And I'll just live with it, whatever I get. There we go. So now you can see that this graph is going to be stretched, and it's going to be upside down, and it's shifted to the left because that's -1. It went -1 for the h, and it went +3 because of the positive k value. So now you can see combination what a, h, and k do as they're all working together to change the parabola's location and possibly its shape and its direction. All right, got a couple more things here to practice, problems you're going to run into. Describe the transformation compared to the parent function. Remember, the parent function is the vertex is at 0, 0, and a is equal to positive 1. So let's see what changes on these. F of x equals x plus 6 squared. All right, so I see here that a is equal to 1. That means we've got a parabola that faces up and it's not stretched or compressed. H is equal to negative 6 and k is equal to 0. So in this case, we've got our h value is shifting the graph. So this particular graph, describe the transformation. We're going to say the graph shifts. Now h is negative 6. That means it's going to shift left 6 units. That's all that happens. The graph shifts 6 units to the left. It doesn't change shape, it doesn't change direction, and it doesn't go up or down because there's no k value. Take a look at the next one. F of x is equal to negative 2 times x minus 1 squared minus 8. We got an a value of negative 2. We got an h value of positive 1 and a k value of negative 8. We got a lot of things going on here. Hey, let's do this real quick up on the top one. Let's put on here that we know it's going to shift left. It's going negative 6 to the left. K does nothing and A does nothing. All right, the A is negative 2. That means it's going to now be down and it's going to be stretched. H value equals 1. That means it's going to move right 1. That's positive 1. The K value is negative 8, and that means it's going to go down 8 because the downward movement is negative 8. So the way I describe this is the graph faces down, is stretched, and shifts 1 unit right and 8 units down. Lots of description there to describe what happened to our graph, all because we know what A, H, and K do. Last one. F of x equals 1/2 times x plus 2 squared plus 3. All right, let's identify our values. A is equal to 1/2. H is equal to negative 2. We flip the sign. K is equal to positive 3. All right, what does the 1/2 do? Our graph is still facing up, so it doesn't flip down, but the 1/2 means we are compressing the graph because it's between 0 and 1. The h value of negative 2 means we're moving to the left because that's a negative movement on the x-axis. The k value is positive. That means we're moving up 3. So our description is the graph is compressed and shifts 2 units left and 3 units up. And there you go. That's how you can take these questions and actually look at the equation and tell me, how does the A value change the shape or direction of the graph? How does the H and K value change the location of the vertex, which changes the location of the graph?